Welcome to another stair building education series. Let's go ahead and jump right into it with our first video. In this video, I will be providing you with a method that you can use to repair a set of stairs, a stairway that has a tall riser on the last step. But before we do that, we are going to need to figure out the total rise, or the rise that we're going to be able to use to calculate our new riser height. Now, the existing riser height is 7¼ inches going all the way up until the last one. And one of the ways you can calculate the riser height will be to use a straight edge or a long level. And to do that, you will level across from the lower level, make a mark on the foundation around here somewhere, or just simply measure up from the straight edge or the level that represents the lower level to the upper level. And in this case here, we have 3 foot 9½ inches. However, I wanted to provide you with another example. You can grab a straight edge or a long level and measure from somewhere over the stairway. And this example here might be the only one you can use if you have walls located on both sides of the outside of the stairway. For example, you might have 2 guardrail walls, one on this side and one on this side, and you won't be able to use the previous method. And if that's the case, you can use this method here and simply level over from the top, the upper level. And I would suggest using a 2x4. Use something that you can level across and mark, because we're going to be using this as a story pole. So again, we have 3 foot 9½ inches, except we now have it laid out on a board. And if that makes sense, then we can go ahead and calculate our individual riser height, which is going to be about 7 9/16 of an inch. And since we have 6 risers, 1, 2, 3, 4, 5, 6. And to calculate the rise, we're simply going to divide the amount of risers into the overall riser height, or 45½ inches, to get our new 7.58 riser. And make sure that you draw the lines all the way across for this, because we're going to use shorter lines that will represent the existing tread height. And to get this measurement, we can shove our board over up against the lowest step and then make another mark. And the difference between these two marks will be the amount of material that you're going to need to install in between the bottom of the existing treads. You're going to remove the treads and put a shim or a shaped board on top of the stringer, and you will see that here in a little bit. And to mark the next one, we're simply going to grab a level or a level and a straight edge, and then level over, make our mark, and again, make a smaller mark here so that we know that this is the existing stairway and the top of our existing tread. So not too difficult. And again, this is going to be the measurement that we're going to use for our shim board. And we will simply work our way up the stairway by going from the second step to the third step with our level. And again, make a smaller mark. And we're going to do that on the next steps throughout the rest of the stairway until we have a mark for each tread. So again, the longer lines are going to represent the top of our new tread or step location. And by using the story pole here, we can simply measure between the marks to figure out the shaped pieces that we're going to need to install on top of the stringer or in between the stringer and the bottom of the tread. So here I have raised the treads to their new location. And all you're going to need to do will be to remove the treads and install a shaped block in between the bottom of the step and the top of the stringer. And that will look something like this. And you can use screws or nails to attach the shaped pieces. And you could even use adhesive if you need to. And keep in mind that each one of these boards will be a different thickness to make this type of repair. So hopefully that made sense. However, if it did not make sense, feel free to let us know in the comment box, along with any questions that you might have about this type of repair. And keep in mind that this is only a suggested repair method, and you might need to check with local building authorities, contractors, your building department, or other building professionals, because they might require you to remove and replace the stairway if they don't like this suggestion. Here is another question that one of our viewers had. They wanted to know how you could figure out the length of the stairway, where the stairway is going to basically start and where it is going to stop. So in order to do that, the first thing we're going to need to do will be to measure the total rise, the overall distance between the top of the upper level and the top of the bottom level. And in our example, we're going to have 8 foot 9 inches or 105 inches. And I do have other videos on this at our website. Go to the stairs link and then look for basic stair building videos. However, I will provide you with a shortcut to that if this makes sense to you, because the first thing we need to figure out is how many steps we're actually going to have in the stairway. And we're not going to be able to do that without this number and then creating an individual stair riser height. So to do that, what I'm going to do is enter 105 into the calculator, which would represent this measurement in inches. And then I'm going to divide that by 7. And if I wanted to have a 7-inch riser, then I would have 15 individual 7-inch risers. However, since most building codes allow us to have a 7 3/4 inch riser, I'm going to try dividing this by 7.5. And that brings us to 14 risers. And keep in mind that this particular stairway was designed specifically for 7.5-inch risers and 14 risers with 13 steps. Now let's go ahead and pretend that this stairway here was 107 inches, and I divided 7.5 into that, and it came up with this number here. Then all I would need to do would be to divide either 14 or 15 into 107. So let's go ahead and do that. So 107 divided by 14 equals about a 7 5/8 inch riser height. And hopefully that makes sense. If it doesn't, again, go to the website and check out some of our other videos, because without the amount of risers, you are not going to know how many steps you're going to have. And without that, you're not going to be able to figure out the length of the stairway. Now, another thing I want to point out is that you might have an overhang. And in our example here, our overhang is 1 inch. And if you don't have an overhang, then it would stop right here, or it could even stop at the floor depending upon the construction of the stairway. Now the reason why I'm showing you this is because you're going to need to add the width of the riser along with the nosing if you're going to have it. This distance here is 1 3/4 inches. We have a 1 inch overhang or a 1 inch nosing and a 3/4 inch thick riser, and your number could be different depending upon the length of the overhang and the width of the riser. So here you can see in this example that the overhang is sticking past just a little bit. And the next thing we're going to need to figure out, and you might or might not need a calculator for this, will be to figure out the depth of the stair tread. And in our example here, it's going to be 10 inches. If your depth is going to be a little wider, then you will have to adjust for that. Keep in mind that in this video, we're not talking about how to fit a stairway within a particular distance. We're trying to figure out the length of a stairway with a certain tread measurement. And to do that, we're just simply going to multiply the width of the tread, 10 inches, by the number of steps. And in this stairway, we have 13 steps. And you're usually going to have one less stair step than the amount of risers. Here we have 14 risers and 13 steps. If the stairway was going to have 13 steps and 11-inch treads, then we're going to have 143 inches in horizontal distance for the length of the stairway. And if I wanted to make that number smaller, I could take 13 and multiply it by 9.5 to get 123.5 inches if my local building codes will allow it. Keep in mind that 10 inches is usually going to be the smallest width for an individual stair tread on a residential stairway, or a stairway that would be located in most homes. So again, our measurement is from the wall here. However, we're going to have to take into consideration that this measurement might not be exactly where we need it to be, especially if we don't allow for the distance right here. And for those of you who do have experience building stairs, pay attention, because this is the biggest mistake I've seen that most stair builders make. And it's something that most architects aren't aware of. And if they are aware of it, I can tell you right now that most of the stairs I built usually ended up with problems if the architect didn't allow for additional space right here. So not too difficult, I hope. However, if you do have any questions, feel free to leave them in the comment area. Or if you have any suggested video ideas or something you cannot find information on, feel free to leave that information in the comment area also. And if I think it's a good idea, I will make a video as soon as I possibly can about it. Here is another viewer requested video, and of course I will put a link from that video to this video. And a couple of the viewers have requested some measurements because they're having a difficult time figuring out how to actually build it with the other video. So in this video here, I will provide you with some measurements and assembly methods along with a few pointers. And one of those pointers would be that you might not need this board here if you're going to attach plywood to the back. And of course, you can use whatever lumber you feel like using. If you want to use treated lumber or even redwood, cedar, anything like that, maybe even a harder lumber, and you don't think you're going to have a problem with it, then feel free to use it. And I really can't tell you what type of lumber to use because in your area, you might not be able to get Doug fir, you might not be able to get white pine or yellow pine, whatever they're using. So with that said, let's go ahead and get started with some of our measurements. And you can see here where this board is going to be a 2x4, 11 inches long, and everything here is a 2x4. This one is going to be 11 inches long, 11 inches, 10 1/4, and then 1'3". These two boards here will be 1 foot 3 inches, and then these two boards here will be 8.5 inches. And then on the bottom we should have a 2 foot 8.25 inch board. And I would also like to point out that I am designing this with my program, and it is quite accurate. However, I have not built this particular set of stairs. So feel free to let us know if there are any problems with the measurements. And even though I think the stairway is going to be strong enough, if you want to add some plywood to the sides and the back, then here are the measurements for those pieces. So at the top we are going to have a board that is 3 foot wide and the same width of our stairway. If you want to make the stairway larger, then simply make this board a little wider along with all of the treads and risers. So here we have 3 foot wide by 1 foot 7.5 inches tall, and then the measurements for the side boards will be 1 foot 7.5 inches, and a measurement on the bottom of 2 foot 9.5 inches, and then 6.5 inch risers all the way up. And again, these are measurements you can change also. However, if you do, you will need to change some of the other measurements in the stairway. And for those of you who are interested, you want to see a variety of different stairways like this along with all the measurements, then let me know in the comment area, and then I can put together a few of them with different sized steps and risers, and even a few more steps. Instead of a stairway with 3 steps, maybe 4 steps, 2 steps, 5 steps, something like that. And for those of you wondering why I don't have the tread measurements here, that's because they are over here. This piece here is going to be exactly the same as this one here. So this measurement here will be the same as this one here, and the risers will be the same as these over here. So you're just going to simply turn this one over, and hopefully that makes sense. Next up, let's go ahead and lay out our bottom board. And you can do that by simply taking these blocks here and setting them on top of the board and then marking this area here. So we're going to have a mark here and a mark here. And we're going to use these marks here to line up our framing studs. And for attaching all of this together, you can use nails or screws. I will leave that up to you. And if the stairway is going to be located outside, you might want to use galvanized or zinc coated nails or screws, and a 16D nail might work just fine, or maybe even a 3-inch long screw. And then we can fasten these two boards together along with the first step over here. So you can have a couple of nails coming from the bottom and a couple from the side. And of course our top boards here can be fastened again with nails or screws. And this assembly here should be identical to this one over here, so you shouldn't have a problem there, except for the fact that this board here will need to be located on the outside of this frame assembly, and same over here. And then after that, we can nail our risers to the top. The top of the riser needs to be flush with the top of these boards here. And you might need to cut this one a little shorter. Here we're using a 1x6. That's 5.5 inches tall here. Where down here, you will need to cut a 1/2 inch off to create a 5-inch board here. And these boards can be attached with screws or 8D nails. And you could always use 4 or 5 of them here instead of just using 3 like I have here. And of course, once you start to fasten all of this together, you're going to get a pretty good idea what the stairway is going to look like. And again, you might not need this board over here if you're going to attach the plywood to the perimeter of the stairway. However, I'm not entirely sure that the plywood's going to be necessary because this stairway should be strong enough. However, if it isn't, then that would be a good time to strengthen it up by adding the plywood around the perimeter. And of course, I will leave that up to you. And the treads can be attached with 16D nails or screws that are at least 3 inches long. And you can always put 3 nails or 3 screws per board, where I only have 2. And of course, to strengthen this area up here, I want to attach some type of a scrap piece of lumber, maybe a 2x4 or a 2x6. Underneath this section here. And this is going to make the stairway a little stronger. Along with, if it's going to be possible, to add some nails, staples, or screws to the back here to make this part of the stairway a little stronger also. So if we don't put these nails or screws in, then the 2x6 tread, the 2x6 we're using for our step, could actually be a little weak in this area. And you can always use a longer board here, something that goes all the way down, so that you have more room for the nails or screws back here. And you can always nail or screw this block on to the riser before you attach the riser to the framing for the stairway. In this video, I will provide you with the top 5 stair building codes, in my opinion, that you will need to be aware of when building a set of stairs with a landing. And the first one on the list will be the minimum width of the stairway, and that will be 36 inches. Now that is 36 inches after everything is finished. After the drywall has been installed and after any of the wood trim has been installed. So if you have a stairway that is going to be in between 2 walls, then you might want to allow for anything you're going to be adding to the side of those walls, like drywall, wood trim, or skirt board. Next up on the list will be the minimum headroom height. And that line will be measured from this line here, or the front of each step, but it will not be measured from the top of the step on any other part of the step. Again, it's going to be measured from this line here. You're going to go straight up plumb or vertically level. And again, it can be measured from the front of each step or from this line here. Next up will be the individual vertical rise. That will be a maximum. It cannot be larger than 7 3/4 of an inch. And I would strongly suggest that you check with your local building authorities, building departments, because they might not be using the codes from the 2021 International Building Code book. Next up, the minimum tread depth will be 10 inches. However, when I first started working, it was 9 inches, and the vertical riser height was 8 inches. Next up, let's go ahead and take a look at the minimum width or depth of the stair landing itself. And according to these building codes, the depth of the stair tread will need to be the same or larger than the width of the stairway. And that would be the same for the top or the bottom. So the depth of this landing here will need to be the width of this or larger. And this was something a long time ago that used to have a 36-inch minimum, which would be the same as the minimum width for a stairway. However, they have changed the verbiage on it. So again, these building codes are from the 2021 Residential Building Code book. And for the most part, these are building codes I like. However, if you do not like them, then check with your local building department to see if they have different building codes that might work better for your project or for you personally. Here is another problem that you might have if you have a set of stairs where the treads are routed or dadoed into the stringers, and you have a tread or a riser that is damaged and needs to be replaced. Now, since these steps are inserted into slots that are cut into the stringers, you're not going to be able to just pop them out. And you can see here where these risers are extending into the stringer a little bit because that is what's holding everything together. So if you do have a tread or a riser that is damaged, then you're probably going to need to cut the tread or the riser in half or cut it up into sections. And this can be done by cutting this way and this way. And if you do cut this way, you don't need to cut all the way to the edge. Because if I had a cut going this way and it stopped about here and a cut going this way, I could probably grab a screwdriver or a chisel and wedge it into the cut and then split the rest of the tread and pop that section out. Now, another thing you could be dealing with will be nails or screws that are attached from the back of the riser or that might have been installed going through the tread into the top of the riser. And if this is the case, then you're going to have to be a little more careful removing the step. Otherwise, you could end up damaging the risers and then replacing them also. So again, be careful taking the treads out. And like I said, you might need to cut them into a variety of different pieces before you can remove them. And after you have removed the treads, you might need to remove the wedges, or at least remove a section of the wedges. And I will leave it up to you whether or not you feel you need to remove the riser wedges, because we are going to be installing a support board here. And that support board can be cut out of plywood, OSB, or even construction standard lumber. And I need to point out that the support board we're going to be using will need to be level so that it can support the bottom of the tread, and will not be following the angle of the bottom slot here, unless you're using a different plan than specified in the video. And keep in mind that the support board here might need to be a little lower if the tread is notching over the riser. So make sure you put a little thought into the position of this board. And even though I'm getting a little ahead of myself, I wanted to provide you with a view of the way we're going to be setting up our support boards before providing you with an example of assembling this section before installing it. So we're just going to have a 2x4 here or a 2x6, and we're going to be attaching the 2x6 to our side support boards. But before we install it, we are going to assemble it. And this is going to take a little bit of planning. You're going to want to have everything in the correct spot. And I would suggest cutting this a little bit smaller, maybe 1/8 of an inch, than the overall width that you're going to need to make sure that you can actually slide it into position. And you can always use adhesive for any connecting point where you think it's going to provide you with a benefit. And of course, feel free to use any fasteners that you think will work, nails, screws, dowels, whatever you think is going to work best. And then once you have this built, you can slide it into place and fasten it to the stringer or to the wall framing also. And you could always make the support boards a little bit larger and then use a 2x6 here instead of a 2x4. Especially if the stairs are going to be a little wider, maybe wider than 3 feet. And you could always install an additional support board in the center. So you could use a 2x4 and then a 2x4 support board. And you could always shape this block, maybe remove 3/4 of an inch out of the 2x4 so that it will slide underneath this support board. And you can always install an additional board behind the front of the riser. And you can attach that through the back so that you don't ruin the finish on the front. And before we cut our tread, I want to point out that sometimes you're going to be able to make the tread a little bit longer. You might be able to slide it into one of the slots on one side, and this might require you to cut a little bit off of the bottom of this side of the step. Just make sure that you don't cut it off of the section that's going to be exposed. And hopefully that makes sense. And the next step I would recommend would be to install some type of construction adhesive or sealant. And since I do not provide product recommendations for that, don't bother asking. And if you can slide one side of the tread into one of the slots, then you'll probably end up with a gap on the other side. And if that's the case, you might even be able to pull the tread back a little bit. So you're going to slide it into this slot a little bit and then pull it back to see if you can slide it into the other side so that you won't have any gaps in your new stair tread. In this video, I will provide you with a few examples for how you can make a set of stringerless stairs a little longer. And I would also like to point out that in the first video, I had the decking boards, or the 2x6 that I used for the treads to make the steps, spanning about 30 inches. And one of the viewers pointed out that 24 inches might be max, even though I have seen them span a little bit farther with no problems. However, if this is a problem and you want to build a wider stairway, then I would suggest spanning these units 24 inches on center, or installing one in the center if your stairs are going to be a little larger than 24 inches and a little smaller than 48 inches. And that's about what we're looking at here, a stairway that's a little over 48 inches. Over here, we're looking at something that's a little over 6 feet. And over here, I believe we're looking at something around 10 feet long. So not too difficult. We're just going to space these 24 inches on center to create our stringerless stairways. And you could always build the stairway and then use it. And if it's a little weak, then install another one of these units, or even more than one if you think that's going to be necessary. So again, not too difficult. 24 inches on center, 24 inches from here to here, or from the center to the center. And you might even be able to space them a little farther depending upon the lumber that you're using. However, I won't be able to provide you with much information on that, but can tell you that a harder board, harder lumber, or hardwoods like oak might be able to span a little further, where that might not be the case with a softwood like pine. For example, they might need to be spaced 12 or 16 inches on center. And another thing you can do to make this stairway a little stronger will be to use 2x material or 1.5 inches for the risers. And you could always make the treads a little thicker also. For example, if you use a 3x12, you might be able to space these 3 foot on center. Or even a 4x12, you might be able to space the units 4 foot on center. So another thing you can consider, along with a support brace in the back here. And what this is going to do will be to help you with any irregularities in the ground or on the concrete slab. And again, something like this could always be installed after. If you're walking up a wider set of stairs and you notice that one of these units is moving, then you could always add this support brace or add some type of shim materials underneath these units that are moving. And another thing you could do would be to install another support brace over here. So you could install multiple support braces, use larger risers or larger materials for your risers, and larger materials for your stair treads. Here is another problem that you might be having if you have a concrete stairway leading up to a porch and the last step is a little high. And before we get into that, let's go ahead and take a look at a stairway where all of the risers are the same height. And in our example, we're going to have 7-inch risers all the way through the stairway. And this is typically what we're going to be shooting for when we are building concrete stairs. However, if you have a stairway where the step is a little taller, and this could be for a variety of different reasons, number one being that the stairway wasn't built correctly, or the most common problem you're going to run into is that somebody added materials to the top of the floor. And if that's the case, you can simply remove those materials to make everything work out. Or you can add materials to each step to compensate and make the necessary adjustments to create risers that are all going to be the same height. And in our example, I raised the floor 7/8 of an inch because I have 7 risers. 1, 2, 3, 4, 5, 6, 7 to make it easy on my math. However, you will need to figure out your own riser height, and I do have other videos on that at our website. So at the bottom, we are going to add 1/8 of an inch to that step, and then 1/4 of an inch to the next step, and then 3/8 of an inch or 3 times 1/8 of an inch, whatever we're going to be adding, and then 1/2 of an inch to the 4th step, and then 5/8 of an inch, and then 3/4 of an inch. And that would look something like this after you're done. And I would imagine some of you are thinking that all you would need to do would be to add 1/8 of an inch to each step instead of progressively making it larger. And trust me, that is not going to work at all. So get rid of that idea. Try not to fixate on that one for too long. And if this makes sense, then I have done my job. Now the next job that you're going to need to figure out is exactly what type of materials you might be able to use to solve this problem. And I think about the easiest way to fix this would be to add some type of non-slip tile or some type of a concrete that will bond to the old existing concrete. And if making that type of repair sounds a little difficult, feel free to let me know in the comment area. And I will try to make a couple of more videos on a few different ways that you might be able to add materials to a concrete stairway to eliminate the large riser at the top and have all of the risers the same size. In this video, I am going to show you how you can fix a stairway that has a low first step. Now, this is going to be a lot easier than fixing a stairway. So what we're looking at here is a stairway that is built correctly. Each step has a 7¼ inch tall riser, and then a stairway with a low first step. Now, this is 1 inch smaller than the rest of the steps in the stairway. And basically, like we did with the other video where we started with a tall first step, the first suggestion I would like to make, if this is going to work for you, will be to lower the walkway, sidewalk, gravel, soil, whatever it is, and then add additional shaped pieces if needed to create the same riser height. However, if you're dealing with a concrete sidewalk, patio, something like that, this probably won't be an option. And if that's the case, then this next method might work better. So the first thing we're going to want to do is to get a straight edge, maybe a straight piece of lumber, so that we can create a level line to the other section where the upper level is going to be located so that we can get a measurement of the total rise. So not too difficult. We are going to start at the lower level and then grab our level and then make sure that this is nice and flat and horizontally level so that we can measure the total rise or the vertical distance between the upper level and the lower level. And then we're going to simply divide the number of risers, and in our case here we have 6 of them, into the total rise to figure out our new riser height of 7 1/16 inches. However, our decimal shows us that it's going to be just a little bit over 1/16 of an inch. But that's the number we're going to be using. So the first thing you can do will be to remove the treads. However, you can leave the treads on if it's going to work better for you to figure out exactly how high we're going to be raising each one of the individual treads. So the next thing we are going to need to do will be to create a 7 1/16 inch mark so that we can figure out the height of the shaped piece that we're going to need to place on top of the stringers so that we can raise our new tread height up to the correct level. And you can do this one at a time, or you can do it, as I mentioned earlier, with the treads still on. Because if the treads are still on and you put the measurement in where you need it to be, then you can simply measure from this line to the top of the tread to get the desired height of the piece you're going to be placing underneath the treads. And then once you have that number, you can simply cut a few boards to go on top of the lower step. And you can always attach these pieces with screws, nails, staples, and you could even use some type of a construction adhesive underneath these pieces and on top of them if you think that will work best for your project. So not too difficult, right? We put our treads on and we now have the correct height that we need. So you can do this one at a time and work your way up, or you can lay everything out all at once. And this is actually what I would do. I would lay out each one of the riser lines so that I could adjust them if I needed to. For example, if I came to here and I drew my 7 1/16 inch line in here, and this was 7 1/4, then I could simply reduce each one of them by 1/16 of an inch to split the difference between a few more of the risers. And if that doesn't make sense, let me know in the comment area. I can always make another video on that. And this could be a problem, especially if you're dealing with a measurement that might be a 32nd of an inch off and on a longer set of stairs. So now that we have this, we can simply go ahead and measure the distance here and then subtract the thickness of our tread, which is going to be 1.5 inches from each one of these measurements so that we can get the height for the shaped strip that we're going to need to cut and attach to the top of the stringer. And for those of you who thought you were simply going to add a little bit or the same amount to each step, you can see here where you are not going to be doing that. Each one of the pieces that you cut will be a different height. And if you remember that I mentioned earlier that you could always lay everything out with the existing treads still in place and then measure the distance here, then you can see here how this would work. So 5/8 of an inch strip there, a 1/2 inch strip here. We're simply going to work our way up 5/16, and then of course 1/8 of an inch. And then we're simply going to rip the strips and attach them to the top of the stringer and then reattach our treads so that they will be located exactly where we need them to be. Now for some of you, you might have noticed that the measurements between the strips might not provide us with the exact riser height that we need. So if you are looking for a perfect step, then you might need to calculate all of these shaped pieces of lumber in maybe a 32nd of an inch measurement. And I'm just throwing that out there. However, I don't think it's going to be necessary because most of our local building codes allow us a 3/8 of an inch maximum variation. And the most that we're probably going to be off in this video will be about 1/8 of an inch between all of the steps. And trust me, 1/8 of an inch when building a set of stairs is going to be close enough. So there you have it. And of course, now you have another method to repair a set of stairs with a low riser. Now, I didn't mention, even though this would be obvious, that you could always remove and replace the entire stairway or recut the stringers to make everything work also. And this is the 4th video in our series of dealing with problems at the top or bottom with the step measurement. And this would be the riser, whether or not the riser is too high or too low. And in this one, we are going to show you how to fix a stairway that has the top riser that's a little too short. And you're probably wondering how in the heck it ever got built that way and why. It's going to be your job to fix it. But that's not my job. My job will be to provide you with another way to fix this, and I definitely recommend watching the other 4 videos. And I will have a link to that playlist in the video or comment area. The first thing we're going to do with this particular stairway will be to take it apart. And when we take it apart, I will leave it up to you if you want to use new materials. While you're taking it apart, you could end up breaking some of the components. Or like I said earlier, watch a few of the videos and see if another one of those repair methods makes more sense for your project. So the next step here will be to find the overall total rise. And that will be the finished floor, the top of the finished floor on the bottom and the top of the finished floor on the top. And in our case here, we're going to be dealing with 3 foot 4.5 inches. And since we have 6 risers, we're simply going to divide the number 6 into this number, which would be 40.5 inches. Once we divide 6 into that, we're going to get individual riser height measurements of 6 3/4 inches for each step. And those will be the measurements that we are going to try to create the new stairway with. So the next step for this repair will be to lower the ledger. And since we're going to be working with a 6 3/4 inch riser height, you can figure this a few different ways. If you're going to be using the same material for the flooring or decking that you're going to be using for your treads, then you can simply measure from the bottom of the decking to the bottom of the decking, which would be 6 3/4, or measure from the top to the top of the ledger, and then add the thickness of the tread, which in our case is going to be 1.5 inches, to the 6 3/4 inch measurement. In the next step, we will be modifying the stringers to make this repair, and you could probably use this same method in the other examples. You're just going to need to do it a little differently. So the next thing we are going to do will be to figure the difference. We had 7 1/4 inch risers before, and now we have 6 3/4 inch risers. And if we subtract the 2 numbers, we're going to end up with a 1/2 inch difference between those risers, suggesting that we are going to need to take a 1/2 inch off of our first step. But that isn't going to work for our next step. We're going to need to add another 1/2 inch to that measurement and take 1 inch off of the second step. And you can always check to make sure that these measurements are working out by measuring the distance between your new lines. So we're going to be adding a 1/2 inch to each measurement that we are going to be deducting from the stair stringer as we work our way up the stringer. And we're going to be able to double check those measurements if for some reason you mess them up or think that you might have messed them up. So again, 1/2 inch, 1 inch, 1.5 inches, 2 inches, and 2.5 inches off of the top. And you can see here where all of the measurements are working out to the desired riser height we're looking for. Now the next thing I want you to do before you cut the stringer will be to put it back in place and double check all of the measurements here to make sure that everything looks good. And for those of you who want to use this method for the other repairs that might require you to add materials to the stringer, then you could see here where something like that might work out for you also. So instead of cutting materials off, you would just simply be adding materials to a stringer that you could use to double check all of your measurements in the same way you're doing here. So we've moved our ledger. We have this fixed. And now all we need to do is start trimming some of the stringer so that we can fix someone else's mistake. Or, I hate to even admit it, you might be fixing your own mistake. And don't feel bad because I've had to do something like this myself. So after we have cut the stringer, I went ahead and left the lines that represent the old top of the stair stringer height, just to give you an idea of what we did. And of course, something else that might help you figure out what we're doing. Now, I also need to point out that this type of repair method on longer stairs might not work. Because as you can see, the width here, the structural strength of the stringer is going to be getting smaller. And if we added a couple of more steps to the stairway, we could end up with a weak stringer. So keep in mind that this particular repair might not work for your project. And if it doesn't, don't worry about it because now you have another way to fix something like this if you're dealing with a shorter stairway. And after you've double checked your stringer, you can use this here as a pattern to mark the rest of the stringers, or even new stringers if you are going to use those. In this video, I will be providing you with a method that you can use to repair a set of stairs, a stairway that has a tall riser on the last step. But before we do that, we are going to need to figure out the total rise, or the rise that we're going to be able to use to calculate our new riser height. Now, the existing riser height is 7¼ inches going all the way up until the last one. And one of the ways you can calculate the riser height will be to use a straight edge or a long level. And to do that, you will level across from the lower level, make a mark on the foundation around here somewhere, or just simply measure up from the straight edge or the level that represents the lower level to the upper level. And in this case here, we have 3 foot 9½ inches. However, I wanted to provide you with another example. You can grab a straight edge or a long level and measure from somewhere over the stairway. And this example here might be the only one you can use if you have walls located on both sides of the outside of the stairway. For example, you might have 2 guardrail walls, one on this side and one on this side, and you won't be able to use the previous method. And if that's the case, you can use this method here and simply level over from the top, the upper level. And I would suggest using a 2x4. Use something that you can level across and mark, because we're going to be using this as a story pole. So again, we have 3 foot 9½ inches, except we now have it laid out on a board. And if that makes sense, then we can go ahead and calculate our individual riser height, which is going to be about 7 9/16 of an inch. And since we have 6 risers, 1, 2, 3, 4, 5, 6. And to calculate the rise, we're simply going to divide the amount of risers into the overall riser height, or 45½ inches, to get our new 7.58 riser. And make sure that you draw the lines all the way across for this, because we're going to use shorter lines that will represent the existing tread height. And to get this measurement, we can shove our board over up against the lowest step and then make another mark. And the difference between these two marks will be the amount of material that you're going to need to install in between the bottom of the existing treads. You're going to remove the treads and put a shim or a shaped board on top of the stringer, and you will see that here in a little bit. And to mark the next one, we're simply going to grab a level or a level and a straight edge, and then level over, make our mark, and again, make a smaller mark here so that we know that this is the existing stairway and the top of our existing tread. So not too difficult. And again, this is going to be the measurement that we're going to use for our shim board. And we will simply work our way up the stairway by going from the second step to the third step with our level. And again, make a smaller mark, and we're going to do that on the next steps throughout the rest of the stairway until we have a mark for each tread. So again, the longer lines are going to represent the top of our new tread or step location. And by using the story pole here, we can simply measure between the marks to figure out the shaped pieces that we're going to need to install on top of the stringer or in between the stringer and the bottom of the tread. So here I have raised the treads to their new location. And all you're going to need to do will be to remove the treads and install a shaped block in between the bottom of the step and the top of the stringer. And that will look something like this. And you can use screws or nails to attach the shaped pieces. And you could even use adhesive if you need to. And keep in mind that each one of these boards will be a different thickness to make this type of repair. So hopefully that made sense. However, if it did not make sense, feel free to let us know in the comment box, along with any questions that you might have about this type of repair. And keep in mind that this is only a suggested repair method, and you might need to check with local building authorities, contractors, your building department, or other building professionals, because they might require you to remove and replace the stairway if they don't like this suggestion. In this video, I will provide you with a few ideas you can use if you're interested in installing some type of an opening for storage access underneath a stairway that will be built like this. And this is the first one in a small series. I'm going to try and create a few different stairways to provide you with a few different openings and where those openings and why those openings might be better located in certain areas than others. So first off, let's go ahead and take a tour of the stairway. I want to provide you with the walls that are going to be non-load bearing, and that will be this area here. The rest of the walls in the stairway are going to be supporting some type of a load. And even though these wall studs are supporting the stairway, an engineer might not find them necessary. However, this wall will be, it's going to be supporting the floor joist here and the upper part of the stairway. And these wall framing studs will also be supporting the floor framing and will be considered load-bearing walls. Along with this wall here, you can see where this wall here is supporting the landing and the top of the stairs. And if we go over to the other side, you can see where the joist for the landing are also being supported by the wall framing over here. Next up, let's go ahead and take a look at the top wall. You can see where the stringers are going to be connecting to a ledger that is attached to this wall, along with the floor joist. Now, I don't have any joist in this area, and if your joists are running parallel to the wall, this might not be as big of a deal. However, if the joists are sitting on top of the wall, then it would be fair to assume that this wall here is going to be supporting a little more weight. So next up, let's go ahead and remove the wall framing studs here so that you don't get confused. These are going to be load-bearing studs. However, in most cases, these will not be. If you have a stairway that's really long and you remove the wall framing studs and you walk up the stairs and they are a little weak, then you might think about reinstalling them. Or at the very least, when you install your openings, you provide some type of support so that the stairway is not bouncing up and down as people walk up and down it. So here's one way you can frame an opening. And again, since I wouldn't consider this to be load bearing, I could simply frame something like this. And if you do end up with a situation where you want the baseboard to run through the opening or the bottom of the opening, then you could always build it up by adding one or more sill plates as another option. Take a look at it there, how this is going to connect to the stringer. And if you are going to use an area underneath the stairway for storage, then you might consider contacting your local building and safety department, because most storage areas underneath the stairway have to be fire rated. And that might require you to use Type X 5/8 drywall. And if you drywall, you might need to install some ceiling backing like we have here. And again, if you are going to run the base through your base trim, then you probably won't be removing the lower framing plate. However, if you are going to install a door, something with hinges, then you might need to remove the lower framing plate. Again, another option for your openings. And something else I like to do will be to run the framing stud down to the wood framed flooring like this to prevent this right here. This small piece right here often splits. So another thing to consider when you are doing something like this. And of course, the most common place to put a doorway in a stairway like this will be in the tallest wall. Or should I say, a wall that will allow some type of an opening and full height door. And to do this, you can simply add a header, some trimmers, and then cut the bottom plate so that you can remove that section of the sill plate. And make sure that this section and this section of the doorway is securely fastened to the floor framing. You do not want the wall to be moving when you are opening and closing the door. And of course, with this type of design, the existing ledger can remain attached to the wall, because you can simply cut whatever studs you need to install the door header. And you could always do something like this if you need to make the opening a little wider. And what I did here was added a 1x4 instead of a 2x4. And even though I'm making this suggestion, this might not be something an engineer is going to want to see. So I would take into consideration the weight and the load above that might need to be sitting on top of a full-length trimmer. And if that's the case, you could always notch into or reframe this corner by turning the studs around or rotating them 90 degrees to create a corner like this over here. So another option you can consider. And you could always install another full-length stud if you want to, depending upon the price of lumber, of course, to fill this area right here and stop the header over here. For example, instead of having the header go over to this king stud, you would install another stud in here and then stop the header at that stud. In our next example, we will install a header that will be a little bit lower, and then we will build up the sill a little higher. And again, you can always build the sill up as high as you need to by adding more framing plates or filling this area in like you would, framing it like you would the bottom of a window, where you might have a upper sill plate here with studs underneath the sill plate, or studs in between the top of the bottom framing plate and the bottom of the door sill. And since this is a load-bearing wall, we are going to need a header in here, and in most cases a 4x4 should work. However, if you're not sure, go to a bigger header, a 4x6, a 4x8, or contact a structural engineer for more information about your project. And if you need to, you could always remove the sill plates. And again, if you need to, you could always remove the sill plate like we did on the other walls over here. And in our last example, we will raise the header a little higher, just in case you have a specific door size that needs to fit in this space. And keep in mind that by raising the header up, you're going to have a weak spot in the drywall on the other side. Now, this might not be that big of a deal. You might be able to get away with gluing the trim to this section of the drywall. However, that's not going to be the case if you move the header up a foot. And for those of you wondering why I'm providing this example, it's just to provide you, the viewer, with a little more information if you decide to do something like this. Just keep in mind that if the opening is too large, then you might need to replace the ledger with some type of a support beam to support the joist that we have here. And I'm not about to suggest that this is going to work here. Again, another reason why you might think twice about doing something like this instead of lowering the header to where the header can actually be attached to the ledger and provide you with the structural support that you need to frame your new storage opening. Here's something that might be helpful for anyone who is trying to cut a tread, and this might work for risers also, that needs to fit in between two walls. And they actually make a jig that you can purchase. And there are a couple of other videos that I found showing how you can make your own jig to cut these treads. However, one of our viewers suggested that what if you're only going to be doing a few steps and you don't feel like making your own jig or purchasing one? And if that's the case, something like this might work just fine, but you are going to need a couple of clamps. However, these clamps could also be replaced by screws. If you could run a screw down through these two boards, you're going to need at least 4 screws. And that would be one over here, one around here, and one around here, if you're not interested in purchasing the clamps. And you can see here where we extended a piece of scrap wood. You're going to need something like this and a straight board. However, these boards don't need to be as long as I have them. You could always make them a little shorter. And of course, the front board is going to go up against the tread or the face of the tread. And this really won't matter if the tread has a nosing on it or doesn't. And I would strongly suggest for anyone who's going to do something like this to cut all your scrap pieces and do one step and make sure that you understand the process of what you're actually doing. And you can see here where everything is square. However, if you have a situation where the wall is angled just a little bit, then you're going to hold this board here tight up against the wall. And don't worry about what the back looks like, because everything you're going to be focusing on will be based off of the front, your guide board that is under these two pieces. And let's go ahead and take a look at the bottom to get a better idea. The guide board is straight and tight to the front of the tread, and you have clamped everything together. Then you can go ahead and move it over and then place the guide template on top of your tread materials and tight up against the front of the tread or the front of the lumber there. And I'm also providing you with 2 different examples. This was the first jig that we created in the video, and this one here was the second one. And you can see where it's nice and tight. And I would imagine by now you're starting to get a pretty good idea what we're doing. However, if you don't, and this isn't making any sense, then I'm not about to suggest that you leave any questions in the comment area and you're going to be doing the work, then maybe purchase one of the jigs. And of course, you will need to draw a line here. You can see where the line is going to be drawn here. And also pay attention to any gaps that you might have when you have this board up against the wall. Because if there's a gap over here, a gap over here, or a gap in the center, then you will need to make more adjustments before cutting the tread. If it is not going to be a straight line, then do not cut a straight line. Kind of curve it if possible. And of course, if that is a problem, then you might need to make a few different pieces. For example, you might need to put a small curve on one end. And that's going to work out good with your scrap pieces of wood. However, that's not going to work good with a stair jig that you might have purchased for $100 or $200. Also providing you with another example of a problem you could run into. So you can see here where this part of the step is a little more square at a 90-degree angle, where this side over here is not square. However, it is shaped to fit in the wall. And it's going to look pretty good if you don't have any deformed sections of the wall. So after you have cut it, you can go ahead and put it into place. And if everything looks good, then you you have done your job without spending a lot of extra money on a fancy stair jig that you're only going to use once.